Underneath that, there's no oxygen, no life. And down there we found conchs and conch shells and hermit crabs that had fallen into the hole and suffocated.
Something is hiding nearly 400 feet beneath the surface of the Caribbean, and for thousands of years, no human being knew what was waiting at the bottom. From above, the Great Blue Hole looks almost unreal, a perfect circle carved into the ocean over 1,000 feet across. But beneath that calm blue surface is a vertical shaft plunging into darkness where sunlight can no longer reach. Divers exploring its upper depths were amazed by enormous stalactites clinging to the walls, silent evidence that this underwater abyss was once a massive dry cave before rising sea levels flooded it at the end of the last ice age. Before we reveal what lies at the bottom of the Great Blue Hole, hit like and subscribe, because some discoveries are so incredible, they challenge everything we thought we knew about our own planet. Yet one mystery remained unanswered. What was hidden at the very bottom? For decades, no one could find out. The depth was far beyond recreational diving limits. The logistics of reaching the deepest point were incredibly difficult, and below about 300 feet, the water becomes toxic, while all natural light disappears. Then, in December 2018, a team of scientists launched an expedition that finally reached the bottom. What they discovered wasn't just surprising, it changed the way researchers looked at one of Earth's most mysterious underwater sinkholes forever. What they found. What they found at the bottom of the Great Blue Hole was not what anyone expected. A layer of hydrogen sulfide gas creating a death zone where nothing survives, preserved remains of creatures, music, and humans who had fallen into the abyss over centuries. Evidence that the hole is slowly filling itself in, the walls collapsing inward in underwater avalanches that will eventually seal this window into the planet's past. Music and sediment. Layers of mud and debris accumulated over nearly 2,000 years, containing a record of climate catastrophes that may explain one of the greatest mysteries in the ancient Americas. The Great Blue Hole is not just a geological curiosity, it is a graveyard, it is a time capsule, and what scientists have extracted from its depths is forcing a reconsideration of what happened to one of the most sophisticated civilizations the Western Hemisphere has ever produced. The 2018 expedition. The 2018 expedition brought together an unlikely team. Music, Sir Richard Branson, the British billionaire, provided funding and publicity. Fabien Cousteau, grandson of the legendary Jacques Cousteau, music brought diving expertise and scientific credibility. Aquatica submarines supplied the technology, submersibles capable of descending to depths that would kill unprotected human divers within minutes. The mission was to map the Great Blue Hole completely for the first time. Previous explorations had documented the upper reaches, the spectacular stalactites and stalagmites that proved the hole was once a dry cavern, the sharks that patrol the entrance, the reef fish that congregate in the sunlit waters near the surface. But below approximately 300 music feet, the Great Blue Hole had never been systematically documented. The expedition deployed sonar systems, high-definition cameras, and 3D imaging technology. The submersible's music descended in stages, documenting each depth zone, recording water chemistry, mapping the geometry of the walls, and recording everything they found. What they discovered changed everything we thought we knew about this famous underwater landmark, the hydrogen sulfide layer. The first surprise was the hydrogen sulfide layer. At approximately 290 to 300 feet below the surface, the submersibles entered a zone where the water chemistry changed dramatically. A thick layer of hydrogen sulfide, a toxic gas produced by bacterial decomposition in the absence of oxygen, extended across the entire diameter of the hole. Above this layer, the water contained dissolved oxygen. Fish swam. Life existed. Below the layer, oxygen dropped to zero. The hydrogen sulfide created a boundary as absolute as a wall. Nothing that breathed oxygen could survive beneath it. The water below was anoxic, completely devoid of the oxygen that aerobic life requires. This is not unique to the Great Blue Hole. Similar anoxic layers exist in other enclosed water bodies, the Black Sea, certain deep lakes, and underwater caves with restricted circulation. But the hydrogen sulfide layer in the Great Blue Hole was thicker and more pronounced than the expedition team had anticipated. A preservation chamber. It also explains something that had puzzled researchers for years. Why were objects at the bottom of the Great Blue Hole so well preserved? The answer was the anoxic zone. Normal decomposition requires oxygen, and the bacteria that use music it. When organic material, a dead fish, a fallen tree, a human body, sinks into water, aerobic bacteria begin breaking it down almost immediately. Soft tissue disappears within days or weeks. Bones follow over months or years. Eventually, nothing remains but the most resistant materials. But in anoxic water, aerobic decomposition cannot occur. The bacteria that normally consume organic material cannot survive without oxygen. Decay slows to a crawl. Objects that would disappear in weeks in normal water can persist for years, decades, centuries music in an anoxic environment. The Great Blue Hole, below 300 feet, is a preservation chamber. And what the expedition found, preserved, there was disturbing. The debris field. The bottom of the Great Blue Hole is not empty. The sonar mapping revealed a debris field covering the floor, objects that had fallen from above over the centuries since the hole flooded approximately 10,000 years ago. Thousands of conch shells, their inhabitants having crawled over the edge or been swept into the abyss, preserved in the oxygen-free water. Small marine creatures, fish, crabs, and invertebrates, music that had descended below the hydrogen sulfide layer and died when the oxygen disappeared. Plastic debris from the modern era, trash that had drifted into the hole and sunk to the bottom, where it will remain preserved for centuries because the bacteria that would normally break it down cannot survive. And human remains. The missing. The expedition located the remains of at least 2 divers who had gone missing in the Great Blue Hole over the years. Their bodies, preserved by the anoxic conditions, were found on the floor of the hole, identifiable, despite years of submersion. The families were notified. The remains were not recovered. The logistics of retrieval from 400 feet through a toxic gas layer were beyond the expedition's capabilities. The Great Blue Hole became, in that moment, not just a geological wonder, but an underwater cemetery, a place where the missing are preserved in conditions that would allow identification decades after their deaths. The expedition team described the experience as eerie. The submersible lights illuminated a landscape of shells, debris, and organic remains, music, suspended in perfect preservation, untouched by the decay that would have consumed them anywhere else. The darkness beyond the lights was absolute. Music, the silence, was total. The bottom of the Great Blue Hole is a graveyard that never decomposes. The sandfalls. The mapping revealed another unexpected phenomenon. Sandfalls. Along the walls of the Great Blue Hole, the expedition documented cascades of sediment, flowing downward in slow motion. Underwater avalanches that look like waterfalls but move at geological time scales rather than hydrological ones. Sand and debris accumulated on ledges and slopes within the hole are gradually sliding downward. Music pulled by gravity, depositing material on the floor below. The implication was significant. The Great Blue Hole is filling itself in. The sandfalls represent a continuous process of sedimentation that has been occurring since the hole flooded. Material from the walls, from the surrounding reef, from organic debris falling from above, all of it accumulates on the floor, slowly reducing the depth of the hole. The process is not fast by human standards. The sandfalls move imperceptibly and the accumulation is measured in millimeters per year. But over thousands of years, the effect is substantial. The Great Blue Hole, which formed as a dry cavern and flooded when sea levels rose, will eventually fill completely. The abyss that exists today is a temporary feature, a window into the geological past that is slowly closing. The sediment cores. The sediment at the bottom of the hole became the focus of subsequent scientific investigation. In the years following the 2018 expedition, researchers extracted sediment cores from the Great Blue Hole floor, cylindrical samples of the accumulated material, some extending more than 30 feet into the debris layer. The cores contained a record of the past that exceeded anything the expedition team had anticipated. Sediment layers act like tree rings. Each layer represents a period of deposition, material that settled to the bottom during a specific interval of time. Storms deposit different material than calm periods. Wet years leave different signatures than dry years. The chemistry of the sediment reflects the conditions that existed when it was deposited. By analyzing the cores, scientists could reconstruct the environmental history of the region over nearly 2,000 years. They found evidence of major hurricanes, storm layers that corresponded to known historical events, calibrating the geological record against the documentary record. They found evidence of climate variations, shifts in rainfall, temperature, and ocean chemistry that affected what material washed into the hole and how it was preserved. And they found evidence of drought, severe, prolonged drought that occurred from approximately 800 AD to 1000 AD. The Maya collapse. The timing was significant. This was the period when the Maya civilization collapsed. Music. The classic Maya, the civilization that built Tikal, Palenque, Copan, and dozens of other cities across southern Mexico, Guatemala, Belize, and Honduras, reached its peak from approximately 250 AD to 900 AD. The Maya developed sophisticated mathematics, astronomy, writing, and architecture. Their cities contained pyramids, palaces, ball courts, music, and astronomical observatories. Their population may have exceeded 10 million. Then, beginning around 800 AD, the cities were abandoned. The construction stopped. The monuments were no longer erected. The population dispersed into smaller communities or disappeared entirely. By 1000 AD, the great cities of the classic Maya were empty, reclaimed by the jungle that still covers them today. The cause of the Maya collapse has been debated for over a century. Warfare, disease, overpopulation, environmental degradation, political fragmentation, every theory has supporters and critics. No single explanation has achieved consensus, but the sediment cores from the Great Blue Hole added a crucial piece of evidence. Taam Ja Blue Hole, Mexico. The Great Blue Hole is not the only blue hole that has yielded disturbing discoveries. In the Yucatan Peninsula of Mexico, another blue hole has challenged scientists' understanding of these formations. Taam Ja Blue Hole sits in Chetumal Bay, near the border between Mexico and Belize. The name means deep water in Mayan, an appropriate designation for a feature that may be the deepest blue hole on Earth. Initial measurements in 2023 recorded a depth of approximately 900 feet, already deeper than the Great Blue Hole's 400 feet. But the measurements did not reach the bottom. The instruments were lowered as deep as the cables would allow. They recorded music depth, temperature, salinity, and water chemistry as they descended. But when the cables reached their maximum extension, the bottom was still not in sight. Subsequent expeditions extended the measurement capability. The current recorded depth exceeds 1,380 feet. The bottom has still not been reached. More disturbing than the depth was what the instruments detected. At a certain depth, the temperature and salinity of the water changed abruptly. That shift suggested the water at that level was not coming from above, but from somewhere else. The hypothesis is that Taam Ja Blue Hole connects to a network of underwater caves and tunnels that extend beneath the Yucatan Peninsula, a network fed by different water sources than the surface bay. The Yucatan is underlain by a vast network of flooded caverns called cenotes. These caves extend for hundreds of miles, connected by passages that have never been fully mapped. If Taam Ja connects to the system, it may not be a simple sinkhole, but a window into an underground network of unknown extent. Music. What else might be in that network? What might the caves contain? What might have fallen into them over the millennia? It remains unknown. The bottom of Taam Ja Blue Hole has never been seen. What it contains is still waiting to be discovered. Dahab's Blue Hole, Egypt. Egypt's Blue Hole presents a different kind of horror. Located near the resort town of Dahab on the Sinai Peninsula, the Blue Hole is a submarine sinkhole approximately 300 feet deep. It is considered one of the most dangerous dive sites in the world. The feature that makes it deadly is called the Arch. The Arch is a tunnel connecting the Blue Hole to the open sea at a depth of approximately 180 feet. Divers are drawn to it, and the challenge of swimming through the passage and emerging into open water is a temptation that has proven fatal dozens of times. The problem is nitrogen narcosis. At depth, the nitrogen in compressed breathing air begins to affect brain function. Divers experience impaired judgment, confusion, and euphoria, a state sometimes called the rapture of the deep. The deeper the dive, the more severe the narcosis. At the depth of the Arch, many divers are already significantly impaired when they attempt to enter the tunnel. The tunnel is longer than it appears. The distance to the exit, the darkness, the disorientation, all combine to trap divers who entered believing they could make it through. More than 200 divers have died in Egypt's Blue Hole. The most documented death is that of Yuri Lipsky, a Russian-Israeli diving instructor who died in April 2000 while attempting a deep dive to approximately 300 feet. Lipsky was wearing a helmet camera. The footage he recorded shows his descent into the Blue Hole, his increasing disorientation as nitrogen narcosis took hold, his attempts to control his buoyancy, and his final moments on the bottom of the hole as his air ran out. The footage was recovered with his body. It remains one of the most disturbing pieces of diving footage ever recorded, a first-person document of death by narcosis, filmed by the victim as it happened. The Blue Hole at Dahab continues to attract divers despite its reputation. The bodies of those who do not return are sometimes recovered. Others remain at the bottom, preserved in conditions that will music maintain them for decades. Dragon Hole, China's Dragon Hole, adds yet another dimension to the Blue Hole music phenomenon. Located in the South China Sea, Near the Paracel Islands, Dragon Hole was measured at approximately 987 feet deep, shallower than Taam Ja, but still among the deepest blue holes documented. Like other blue holes, Dragon Hole contains an anoxic zone, where oxygen disappears and normal marine life cannot survive. Music. But what scientists found living in the oxygen-free water was unexpected. Microbial communities, bacteria and archaea had adapted to the extreme conditions. These organisms did not require music oxygen. They metabolized sulfur, methane, and other compounds that would be toxic to aerobic life. And among these microbial communities, researchers identified viruses. Approximately 1,700 distinct viral types were catalogued in samples, music from Dragon Hole, many of them previously unknown to science. The discovery raised questions that extend beyond the specific site. Blue holes around the world contain isolated environments, cut off from normal ocean circulation, with unique chemical conditions and limited exchange music with surrounding waters. Each blue hole potentially contains microbial communities found nowhere else, organisms adapted to specific conditions that exist only in that particular location. And each microbial community potentially hosts viruses that have evolved in isolation, infecting hosts that exist only in that environment. Music. What these viruses are, what they might do if released into broader circulation, whether they pose any risk to organisms outside their isolated habitats, these questions remain largely unanswered. The blue holes of the world function as biological laboratories, isolated environments where life has evolved along pathways different from the broader ocean ecosystem. What has evolved in those environments is music only beginning to be catalogued. Dean's Blue Hole. Bahamas. Dean's Blue Hole in the Bahamas represents music, yet another variation on the phenomenon. Located on Long Island, music, Dean's Blue Hole, is the deepest known blue hole in a saltwater environment directly connected to the ocean, reaching approximately 660 feet. The hole is roughly circular, with steep walls that drop quickly from a shallow shelf, music, to extreme depth. The clarity of the Bahamian water allows sunlight to penetrate deep into the hole, creating an environment that is simultaneously beautiful and deadly. Free diving competitions have been held at Dean's Blue Hole. Athletes descend on a single breath to depths, music, that would kill recreational divers using compressed air. The hole has also claimed victims. The combination of accessible entry, extreme depth, and clear water creates a temptation that some divers cannot resist. Those who exceed their capabilities, who suffer equipment failure, or who simply misjudge the demands of the environment, sometimes do not return. The bottom of Dean's Blue Hole is covered with fine sand that has accumulated over millennia. What lies beneath that sand, what may have fallen into the hole over the thousands of years since it formed, is unknown. A race against geological time. Blue holes are found worldwide, wherever limestone bedrock has been dissolved by groundwater to create caverns that later flooded. Each one is unique, with its own history, its own sediment record, its own debris accumulation, its own preserved remains of creatures and humans who entered and did not return. The Great Blue Hole off Belize has provided evidence of ancient climate catastrophes that may have toppled civilizations. Taam Ja in Mexico has revealed a depth that measurement instruments cannot reach, connected to underground systems of unknown extent. The Dahab Blue Hole in Egypt has taken hundreds of lives, preserved on film in some cases, their final moments documented by their own cameras. Dragon Hole in China has yielded thousands of previously unknown viruses, evolved in isolation in conditions that exist nowhere else on Earth. Dean's Blue Hole in the Bahamas has served as both athletic arena and grave, its sandy bottom concealing whatever has accumulated across the ages. The common thread is not just geology, it is the unknown. Each blue hole represents a place where human knowledge ends and mystery begins, depths that exceed easy exploration, conditions that challenge current technology, isolation that has let ecosystems evolve independently for thousands of years. The 2018 expedition marked the start of a much bigger journey, not the end of one. The discoveries inside the Great Blue Hole revealed new mysteries that scientists are still working to understand. Every blue hole on Earth is like a natural time capsule, preserving clues about ancient climates, ecosystems, and events that can't be studied anywhere else. In Belize, sediment collected from the bottom of the Great Blue Hole even provided evidence that prolonged drought may have contributed to the collapse of the ancient Maya civilization. But these underwater archives won't last forever. Sand and sediment continue to build up, slowly covering the evidence hidden below. Over time, valuable clues about past climates, extinct ecosystems, and unanswered historical mysteries could become much harder or even impossible to study. The expedition reached the bottom of the Great Blue Hole and uncovered remarkable discoveries. Yet scientists believe that many more secrets may still be waiting inside the world's other unexplored blue holes.